is our classes are rules of the differentiation. First, I will show you three different kinds of topics belong to rule of differentiation. We are talking about the derivatives, okay, the derivative, the sum and the difference rules. If the first problem is if f of 3 equals 4, and then the derivative of f of 3 is equals 3, then g3 equals -7, and then g prime of 3 equals -4. What is h prime of 3? Okay, let's remember this concept. The sum, the sum rule says this idea that we are able to write it in this way. For instance, if we have open this u of x plus b of x here, I mean parenthesis here, cross crochet here equals u prime of x plus b prime of x. This whenever u of x and b of x are the differentiable. All right, this is very important to understand, and this is a main concept to solve problems. Now, let's show you how work in our problems. All right, you know that h here, h of x, let me write it is equals g of x, right, plus here in our case f of x, and that the function f of x, the function of f of x and g of x here, because we have f of x is are differentiables. Okay, so to find here, this is the question, to find h prime of 3. First apply the sum and define the the formula for h primes of 3. We have to find the sum first, and then what is the sum? We will have here, let me write it, h prime of x, okay, equals the sum. We have to sum gx here plus f of x, fx here prime. This is equals will be equals g prime of x, okay, plus f prime of x. This is the formula. So now we have to plug in x equals 3. X equals 3, right? We have to plug it in x equals 3 and use what is f prime 3 of 3 equals 3. And everything right here. So let's plug it in here then. Let's erase it. I will erase it all this and then start it again in to write the formula, everything. So right here, we have to plug it in here. We have our formula here, h prime of x equals g of x plus f of x here. Prime equals g prime of x plus f prime of x. Okay, so now we have to plug it in x of all this information. So just write it, and the first step, f prime 3 h prime 3 of 3 equals, yeah, because there's a question, what is h prime equals here. We have to write it g prime of 3. Look at this, and the formula here, this is our formula here, plus f prime of 3, right? We have it right here. Okay, so now this will be equals here. We will have in this this example we will have here -4. So how much is here? G prime of 3 is -4. Do you see right here? -4 plus f prime. What is f? What is f? Is f prime right here is equals 3 plus 3. Okay, then this will be equals, here you added -1. So the answer or our conclusion is h prime or derivative of x is equals is 3 right here. Let's write it 3 plus -1. See, this is our conclusion in our problem. Let's try to find another one. Let me show you another problem like this, using sum and difference rules. Using these rules and the sum and the difference. Now our problem is equals, let's write h of x, okay, equals g of x plus f of x. And in this case, if f of -10 equals -1, right? Then f prime of -10 equals 1. See, g of -10 equals -7, and let's write g prime of -10 equals 7. Okay, what is the question? What is h prime of -10? Okay, so let's write it, do a whole process. h prime of x equals open quotient, and then let's write a g of x plus f of x. Okay. Here we will have gx g prime of x plus f prime of x. Okay. So just plug it in. We have to plug it in here. Step plug in x equals -10, right? We have to plug x -10 and use all this information here that we in our problem. Then in this case, we will have h prime of -10 here equals g prime of -10. No, not -10. How much is g prime of -10? How much is it? Yeah, -10. Let's write it. -10. And then let's do one more step. And then f prime of -10 too. So here, so substitute here. Plug it in x -10 right here. And then we solve the problem. What is g prime? G prime. What is g prime negative s equals? How much is here? So let's write it as 3. It's 3, not 7 here. Okay, just write it here, 3. G of this one is 3. And then plus less f prime. We have right here is equals 1. Plus 1. Plus 1. So our conclusion here, is 4. We have 4 right here. So our conclusion is and the problem, so h prime is equals a prime of -10 of -10, because that's our question. -10 right here is equals 4. It's equals 4, right? So that's it. Sum and the differentiation. This is one topic that belongs to rules of differentiation. This one kind of rules. All right. Let me show you another topic a little bit different that belong to these rules. Okay. The next problem is we call power rule. This one is power rule. So what I mean this let me write one problem. Find the derivative of we have to find the derivative, okay, of let's think about f of x. Let me show you with the power f of x, okay, equals x to the a power. Let's see you how solve this problem. Some idea, and the power rule says the power rule says let's see. The power rule says that if n means the exponent is a real number, okay, if n is a real number, the derivative of x, and this n means the exponent. Is the exponent is x to the n power. Here, the derivative with this code means the derivative. I told you before. So this will be equals n times x n minus 1. This is the rule, okay? And power rule. So how find the derivative? So, okay, let's go and then solve. This is our problem. It's very, very simple, okay? To find the derivative of f of x equals x to the a power, apply the power rule that I wrote it right here, okay? So then this is the derivative. This is of what? The derivative of x equals x to the a power, okay? It's very easy. How solve it? So apply the rule. Remember the rule? So here we have to write 8 first. Right here, 8. And then write x. See? X. Now 8 minus 1. Remember? 8 minus 1. I write the rule, remember? So now this is the practice. So it's equals. If we simplify here, we will have 8x. 8 minus 1 is 7, right? We will have 7. So our answer, so the derivative of x is equals 8x to the 7 power. See? That's it. Let me show you another problem. It's very, very easy, right? Let me write another problem. Now find the derivative of f of x equals x to the third power. See? Just apply the power rule that I wrote it before. So if we apply the power rule, we will have the derivative of x here equals x to the third power derivative. So this means the derivative. This is equals. How apply this? We will have here this to the 3 to the x times to the 3x, and then write here 3 minus 1, right? 3 minus 1. If we simplify, it's very easy, right? We will have 3x to the second power. See? Very, very easy. This is our answer. So the question of, the derivative of x equals to the x to the third power. So the third power is equals 3x to the second power. See? That's very, very, very comfortable, right? Power of the rule. Another rule of the differentiation, the last one, this is power of the rule. When we're talking about the derivative. The last one is find the derivatives. Find the derivatives of a polynomial. Derivative of a polynomial. Okay. How solve this problem? I mean, let me remember the rule. The rule says the derivative of the derivative the derivative of a constant is 0. The derivative of the constant is 0. Like if we have, for instance, c, the derivative of c is equals 0. All right? The derivative, this is one clue. Another, the derivative of x, derivative of x is wherever x is 1, it is 1. Like, for instance, we have x here, the derivative like this is 1, like that. Okay, so multiply multiple rules. Okay, multiple rules, and the other one multiple rules. So multiple rules apply like this. We have cx derivative, okay, equals x derivative times, equals c, like that. So this is the rules for the derivative of the polynomial. Let me show you one problem. I will erase it here, and then let's try to solve one problem to show you what I mean this little topic. Okay, f of x, the derivative of x is equals let's write 6x plus 8, okay, plus 8. So the derivative. Now simplify right here. We will have 6x here, 6x, but it's right the parentheses, between the parentheses. Let's write the parentheses here, like this. Okay, this means the derivative plus 8, the derivative. With the parentheses, all right, of course, the parentheses. So here, in this, we have to apply the sum rules. Apply here, apply. Remember, we have to apply the sum rule. I write it there, so. And then, if we apply this, take the derivative. Now, take the derivative here. So how much is here? If we take the derivative, we'll have here. Remember, this will be equal 0. The derivative of the constant is equal 0. So 0 times this derivative, remember, is 1, but 0 times 1 is 0. Here is 0. And no, in this one, this is x. This is 0. So the derivative is 6. Here is the derivative of 6x is 1 times 6. 1 times 6 is 1. So plus the derivative of the constant is 0. All right. Then s equals 6. The derivative is 6. So here f of x equals 6. That's very simple. Let me show you another problem. Let's write one more. Write one more problem. So find the derivative of f of x, f of x, f of x. So f of x equals negative 3x Okay, negative 3x plus 25. Plus 25. 24, 25. Let's write 25. 25. Okay, so you can find the derivative in this way. F of x equals negative 3x plus 25 derivative. Okay, this is the way to write, the right way to write our problem when we are working with the derivative of the polynomials. So now this is equals, next step we will have negative 3x derivative of 3x plus derivative of 25. Okay, apply the sum rules here. Apply the sum rule. Okay, or the sum rule, not rules, so the rules. Okay, if we apply that, and we will have here, remember this is 1 times the negative 3 is equals negative 3 plus, what is the derivative of the constant? This is a 1 constant plus 25, always is 0. Okay, always is 0. Derivative of a constant is 0, always 0. So our conclusion here equals negative 3. See, so f of x, f prime of x, or derivative of x is equals negative 3. Right? That's the solution. Rules of the differentiation. The rules of the differentiation. So that's it for today. So thank you so much. I'm waiting for you next time. Thank you.